Hello everyone. As part of learning the Big Data, Hadoop and Spark frameworks, let us look at some introductory concepts of HBase. So where exactly HBase is put into use, how it is different from regular RDBMS concepts, what are the advantages it is offering compared to RDBMS, how do we install it, how do we work with it, all these things. Now, to start with the introduction of HBase. HBase, it's a distributed column oriented database. This is the first difference with regular RDBMS. Whenever we are working with RDBMS, those are row oriented. The data is divided into rows and columns. The major unit of access would be rows. We talk in terms of rows. Whereas HBase, it's a distributed column oriented database built on top of HDFS. So whatever data I have stored in my HDFS, on top of that HBase is built. So you can access the data which is there in HDFS using the HBase concepts. HBase is the Hadoop application to use when you require real-time read or write random access on considerably huge amounts of data or large data sets. Then this was the introduction of HBase. We might argue RDBMS is also allowing me to access the data, and even if the data is growing, we have the concepts of partitioning the data. Why we are going for HBase? Whenever we are working with RDBMS, we first try to see whether the data is limited amounts or whether data is small amounts or huge amounts. When you have huge amounts of data, generally RDBMS, if at all, still the huge amounts of data I want to maintain using RDBMS, it suggests you have to go for replication of the data, you have to take care of partitioning the data, all these complexities will start cropping up. Because of these partitions, replications, we need to take very good care of inconsistencies. Again, when the data is spread across a network with multiple partitions and all these things, the expenses of executing joins, complex queries, triggers, all these things will be increasing, expenses in terms of computation time. So, whenever we are working with huge amounts of data, why aren't we happy with RDBMS? Because of these reasons. RDBMS provides us an option. You can partition the data, replicate it on a network and store it. But because of these scaling issues, because of this scaling, we try to have these inconsistency issues might crop up. Certain operations will cost you more computation time. We are not going towards RDBMS when the data is huge or enormous amounts of data when we have. HBase approaches all these scaling issues from the opposite direction. What do we mean by that? We start with limited amount of nodes, and whenever the data size is increasing, we try to add one more node to the existing system of nodes. So we just go for horizontal scaling without disturbing the existing system. HBase makes it very easy for us. Then, where exactly HBase has started? It actually started as a project at PowerSet in 2006, wherein they were trying to model the Google's big table. That was the first scenario where they thought of going for HBase, and the paper, the Google big table, was just published. In 2007, he started with the Mike Caffarella, he started with a working system, and then Jim Kellerman, he carried it forward and totally built into the first released version, which was bundled into 0.15.0 version of Hadoop in 2007. By 2010, HBase is totally functional, totally carrying all the features whatever are required, and it has become Apache's top level project. And now today HBase is not limited to Google's big table, we are using it in various ranges of industry applications. Then whenever we are working with HBase, what exactly is the data model? When we are working with RDBMS, we know the data model consists of rows and columns. every cell value should have so and so amount of data, what are the data types, we have fixed all these things. When you are talking about HBase, it is trying to access the data from HDFS. There is no fixed data type when you are trying to take data from HDFS. So how do I model my data using HBase? Applications store the data in labeled tables. One more difference compared to RDBMS. RDBMS goes for table. Table has a name, columns have names. Here we are going for labeled tables. I will show you with this example. Tables are made of rows and columns. This is a similarity with RDBMS. Table cells, which are an interaction of rows and columns, are versioned. This is again another difference compared to RDBMS. What do I mean by version? With every column value you are storing, we try to store the timestamp also, just to know what are the versions for that particular column value. A cell's content is an uninterpreted array of bytes. Why are we talking about cell values, uninterpreted byte array? Whatever we are trying to store, the data type by default it will take is byte array. Now say for example, we are trying to store some pictures. Try to see this diagram. What are we trying to do is, in my example, I have 3 rows. Every row will have a row ID, or we also call it as a row key. Normal RDBMS tables also will have a unique identifier for every row apart from the primary key which we are defining. We call it as the row ID. In case of HBase, we call it as row key. So this row key is a unique identifier for every row, and it will be in ascending order, and it is an increasing value. We need to remember about the row key. It will be in ascending order, it is unique for every row, and it will be in increasing order. And the values are auto increment for every row you are inserting. Now we have told that the columns are versioned and they have labels. What do I mean by that? Say for example here, column family contents. So it is like attribute name, or the field name of this table is contents. What is the data type of a content? Content is having image. Here we say family name is content, and this is the family member of that. So this column has a family name called content, and what are the contents having? Image. And for every image, if you see, there are multiple values. If you see, multiple copies are included. So for the same value, you can store multiple copies of the data. Because of this, we are trying to store the timestamp value, right? So if you see that those are the versions. For this example, I have 2 versions for this, 3 versions, so on, just to show the diagram. Then what is the next column? Next column is information, and it is containing 2 members. The information field is containing 2 members. First one is, what is the format of the image, what is the geometrical information or geographical information, whichever you consider, right? So this column is again split into 2 values, but both of them are belonging to the family called information. This is how HBase will try to model the data. Then the same thing is explained here. Table row keys are also byte arrays. So theoretically anything can serve as a row key, and from strings to binary representations. So is there any specific data type for this row key? Those are also byte arrays. So normal data is also stored as byte array, row key is also stored as byte array. So any attribute can become the row key, provided it is having unique values, ascending order and increasing values. And table rows are always sorted by row key, which is the table's primary key. This sort order is also byte ordered, and all table access the data via the primary key. So the major meaning of primary key does not change. Primary key is always used for unique identification of an entire row, right? Row columns are grouped into column families. All column family members have a common prefix. Let me talk about this one. What is the column family name? Contents. Who is the member of contents? Image is a content, right? Apart from image, suppose I am trying to store a student information, right? Student name can be one content, student class can be one content, student date of birth can be a content, yes. So all of them will come in the content family, right? And what each one is having, image is a family member, name is a family member, date of birth is a family member, likewise. But ultimately what is the family name? Contents. Similarly, what is the family name in this example? Information. Who are the members of that information family? Format, geographical or geometric information, likewise. And for every column member, we will have a common prefix. What is the common prefix? The family name will be prefixed with every column name. So in my example, if I want to access this format and the geometric information, how do I access them? Info colon format, info colon geometric. What do you mean by that? Family name colon member of the family. That is how we try to access them. So I have written the same thing here. The column family prefix must be composed of printable characters. If you try to see this one, this family name cannot have any non-printable characters. Just because we are saying it is a byte array, you cannot go for any character which is available on the keyboard. Some characters are non-printable, so they cannot be part of the family name. This is a convention they are using. And the qualifying tail, the column family qualifier, can be made of any arbitrary bytes. Can the family member have non-printable characters? Yes. Only family name cannot have non-printable characters. A table's column families must be specified up front as part of the table schema definition, but new column family members can be added whenever you are requiring. Say for example, whenever you are trying to create the table, first I have created something called as contents, under which I am storing image. In the information I am storing format and geometric information. In the information itself I want to store using which camera I have taken this pic. That camera information also I want to add. Can it be done? Very well, we can update the column definition. But initially you should specify how many columns are having, at least with minimum value. And physically all column members or all family members are stored together in the file system. So even though we are saying HBase is a column oriented data store, sometimes we say it is column family oriented store, because each family with its members will be stored in one location. That is how we try to say. Sometimes they say not only column oriented, it is column family oriented store. Then talking about regions, in HDFS we are trying to split the data into blocks, and the blocks are spread across the network. In HBase the data is horizontally partitioned and we call them as regions. And how do I spread the data? I spread the data across the network region wise. Say for example, in my table I have some 50 rows. 1 to 30 one region, 31 to 50 second region. Say for example, I am dividing my 50 rows into 2 regions. How do we specify the regions? A region is denoted by the table it belongs to. So I should specify what is the table name and its first row, that region's first row. In my example, suppose the table is student table, first row to 30th row. So student, first row is 1, last row is exclusive. So I should specify 30 or 31. I should specify 31. If I am keeping row 1 to row 30 in a region, I need to specify the last row as exclusive. So student 1, 31 should be the region specification. Initially, a configurable size threshold at which point it splits at a row boundary into two new regions of approximately equal size. If you don't specify any split size or region size, by default it will try to divide the number of rows into two equal halves. Until the first split happens, all loading will be against single server hosting the original region. If we are not specifying splitting operation into regions, by default it is expected entire data should be stored with a single server. As the table size grows, we know the regions keep on growing. Regions are the fundamental units which are distributed over HBase cluster, right? Then locking, ma'am, we are distributing the data across the network taking a region. How do we go for locking of the data? Say locking is when I am trying to update, say for example, row 5. If someone wants to read it, how do I do that? Row updates are always atomic by default, no matter how many row columns are constituting the row level transaction. You are updating a student name. Can somebody read his date of birth? Definitely no. It is row updates are atomic no matter how many row columns constitute the row level transaction. So the simplest locking model is the entire row is locked even though you are accessing only few of the columns from the row. Then implementation, how do we go for implementation of that? Just like HDFS and YARN, HDFS and YARN have worker nodes or slave nodes, master node, or we also call them as name nodes, data nodes. In case of HBase, it is consisting of two types of nodes, HBase master and HBase region server, which are called as the worker nodes. So HBase master, it will take care of controlling the entire operation, and region server will be responsible for the region of the data it is taking care. HBase master is responsible for bootstrapping, installation of region servers, all these things HBase master will take care, for assigning regions to registered region servers and for recovering region server failures. All these things are responsibility of the HBase master. Still we say the master node is lightly loaded. So major job is taken care by the region servers. The region servers carry 0 or more regions and field client read or write requests. So they take care of all the read write requests at the region servers only. They are also taking care of region splitting. Suppose I got 50 records into the region which I am holding. Some other region server has got 25 rows. Now, because of updations, because of insertions, the data at my region server has gone to some 80 rows. What should I do? I can hold only 50 rows. So then the region server will take care of splitting these 80 rows into two regions. And once I split the data which I have to inform the same to the HBase master node. Here if you observe the terminology, they will call them as not child nodes, they call them as the daughter regions, which are newly created, the region splits by the region server, they are called as the daughter regions, and the HBase master henceforth will take care of those daughter regions. HBase internally depends on the zookeeper, which will control all the components of HBase, and it ensembles hosts vitals such as location of the HBase meta catalog, and it will try to take care of the address of the current cluster master. It will take care of where are the daughter regions placed, where are the region servers. All such meta information is taken care by the zookeeper. And assignment of regions is also mediated by zookeeper, right? So all these things are taken care by HBase master with the help of zookeeper. And region server nodes are listed in what is the configuration attribute HBase configuration /region servers file. Similarly, the node managers, just like you are trying to store the data node information, Hadoop etc/Hadoop slaves file. So, configuration region servers is the file which consists of the information about region servers. And similarly, simple scripting can be done whenever we are working with HBase. This is how you try to invoke the script. And it also takes care of persisting the data using Hadoop file system API. By default, it writes into the local file system. Thank you.